Hello everyone! I'm excited to be here today to talk about something that, in my opinion, can transform your platform engineering experience, building custom Kubernetes controllers and making your platform more flexible, intelligent, and AI-friendly. My name is Denis. I am a principal SRE for Neuron, an AI-driven data analytics platform at GFK and Nelson IQ. Beyond my core role, I'm focusing on Kubernetes AI reliability engineering and run a YouTube channel and podcast about DevOps and SRE. Agenda for today. Why we are here, how a Kubernetes controller works, case study, promotion, controller, platform engineering integration, and AI agentic capabilities. So, why we are here? My goal today is simple. I want to motivate you to start working directly with the Kubernetes API and custom controllers. Why? Because this is not just about the mastering Kubernetes, it's about growing as a true platform engineer, a better developer experience, and your confidence when tracking the most modern challenges. Why controllers? Kubernetes controllers are the heart of automation inside the cluster. They are not just the part of Kubernetes, they are Kubernetes. Every time you deploy an application, scale a service, or recover from the node failure, this is the controllers working behind the scene. So imagine that happens when you start building your own controllers. You stop just using Kubernetes, you start extending it. To really build a controller, you need to understand the architecture of Kubernetes itself. The control plane makes cluster-wide decision. The Kube API server is the front door, the single place where all interaction happen. The etcd database stores the entire cluster state. Kube scheduler assigns the pods to nodes. The Kube Controller Manager and Cloud Controller Manager run background tasks to keep everything in a desired state. Knowing how these pieces fit together is essential because of your controller becomes part of the living system. When you design the Kubernetes controller, a few architecture components are crucial. CRD. This is how you teach Kubernetes about new type of resources. Enformers. They efficiently watch Kubernetes resources, maintain a local cache, and trigger your controller logic when changes happen, without hammering the API server. Client Go, on the right side of the schema. This is the Kubernetes client library in a Golang. It provides tools for interacting with the API server, managing caches, and building custom controllers. And controller runtime. A high-level library built on top of the Kubernetes client Go. It simplifies controller development by giving you out-of-the-box patterns to reconciliation loops, dependency injection, manager lifecycle, and metrics. By using informers, client Go, and controller runtime together, you can build highly efficient production-grade controllers handling millions of events without overloading Kubernetes itself. Following these patterns makes your platform automation fast, reliable, and safe, crucial for scaling platform engineering system. On this schema, you can observe that controller watches resources through the API, compare the actual state with the desired state, act to fix difference by creating, updating, or deleting Kubernetes objects, reconciling a loop. Let me give you the real-world example, our custom controller for release promotions. In our journey, we create the custom controller to handle application promotion, safely moving application from dev through stable to production. This controller watched specific CRDs, custom resource definition, and took actions to promote, rollback, or validate releases in real time automatically. It made promotion auditable, observable, and resilient, removing friction from the development process. It wasn't just about the deployment, it was about the trust that platform would consistently do the right things. We based it on existing components like Flux, image automation controllers, application CRD, Vault Secret Operator, and our custom controller, add to 10. So this controller wasn't just about promotion. It became a key part of the platform, automating decision and ensuring reliable releases. We made a few important design decisions. We create CRDs for everything: environments, promotion plans, and access control. We keep controllers stateless where possible using in-memory cache. Make them maintainable. Our test coverage in 87%. Observable, OpenTelemetry integration. And reliable with out-of-box leader election. We integrated with the platform engineering system, Port. But platform engineering isn't just about what happens inside the cluster. It's also about what developers see and interact with systems like Port. And Port helps platform teams create internal development portals, a unified place for managing resources, services, environments. To integrate Kubernetes into system like Port efficiently, we use CRD exporter controller. Yes, yet another controller. Internal development portals like a port provide a user-friendly interface to manage the services. And as I mentioned, we use the CRD exporter controller. It's open source. It watched our custom Kubernetes resources, deployments, pod applications, promotion plan, transforms the resources metadata into the formats port understands. Keep the portal always in sync with the live cluster state. This pattern controller-based integration is one of the key superpower of the modern platform engineering. That means developers can real-time visibility into their application without ever touching kube control. So Kubernetes stays complex under the hood, but the user experience stays as simple as possible. And the story doesn't end there. Now the coolest part. We embedded the MCP server directly inside of the controller. MCP stands for Model Context Protocol, a way of AI agent to interact with the systems like a Kubernetes safely and efficiently. Imagine an AI copilot living inside your platform, improving reliability and power to promote, rollback, or scale applications, but in controller, secure, observed way. These agents can trigger promotion based on testing results, suggest rollbacks if anomalies are detected, help debug failed deployments. This is the future. Infrastructure operated with the help of intelligence agent, improving the speed and reliability of operations. And just a few points from my talk. Kubernetes is not just the platform, it's the ecosystem you can extend. Writing controllers grows your engineering skills exponentially. Understanding Kubernetes internals make you better at almost everything: scaling, security, reliability. Combining controllers with the AI opens entirely new opportunities for the platform engineering. So, start to build now. Thank you.